Let's practice taking some basic derivatives. Here are 7 functions. Please go ahead and write them down, pause the video, take the derivatives that you can. Remember to algebraically simplify before you derive, because that's always an easier way to fulfill the process. For the first one, we want to take this x squared that's in the denominator and write that as a negative exponent, so we get 3x minus 4x to the negative 2. Now when we take that derivative, the derivative of 3x is 3. The negative 2 comes down, multiply it by negative 4 to get positive 8. So positive 8x to the minus 2 minus 1, which is minus 3. So that is your derivative. Or you can rewrite that second term as a fraction because you have a negative cubed that moves to the denominator to give you 8 over x cubed. For the next one, let's go ahead and rewrite what's inside and then multiply that outer x in. Square root of x is x to the 1/2. 3 over x squared is 3x to the negative 2. Now let's go ahead and distribute this x from the outside. Remember that x has a power of 1. So we get x to the 3/2. 1 plus 1/2 is 1.5, or 3/2. And then multiply it times that second term. You get plus 3x to the 1 minus 2, which is negative 1. Now let's take that derivative, bring the 3/2 down, subtract 1 from the exponent, that gives you 1/2. And then the negative 1 comes down times the 3 to give you minus 3 to the x minus 1 minus 2, which is minus 2. You can leave this derivative like this, or you can rewrite it. And if you need to rewrite it, you would rewrite it as 3 square root of x over 2 minus 3 over x squared. And that's that first derivative. For the next one, we want to distribute by what some of you would call foiling. Let's distribute the 3 to both the terms in the second factor. 3 times 2 is 6 minus 3x. Then take the x squared and multiply it through. X squared times 2 is 2x squared. X squared minus x is minus x cubed. Now let's go ahead. You can leave it in that order. It's in reverse exponential order, but that's not a problem. Let's take the derivative, y prime. Derivative of 6 is 0. Derivative of negative 3x is negative 3. This 2 comes down, multiply it by the 2 to get 4x to the 2 minus 1, which is just 1. You don't put that 1 there. Bring the 3 down. We're using the power rule over and over again. The exponent of 3 minus 1 is 2. And then you're done. This one has no negative exponents, no roots, so we leave him as he is. For the next guy, we can go ahead and multiply like we did last time, but let's rewrite this term first. So we keep the 3 plus 4x to the negative 1, and the second factor becomes 2x plus x to the square root of x becomes x to the 1/2. Sorry, he got scooted around a little bit. And so now let's go ahead and multiply. We'll multiply the 3 times both first. So 3 times 2x is 6x. 3 times x to the 1/2 is 3x to the 1/2. Now we'll take this second term, 4x to the negative 1, and multiply it over. 4 times 2 is 8. X to the minus 1 times x to the first is x to the 0, which is just 1. And then multiply it by the second term. 4 x to the negative 1 times x to the 1/2 gives you x to the negative 1/2. Remember, we are adding exponents. And the reason why you get x to the negative 1 times x to the 1, we add those together and you get 0. That also, this guy means really 1 over x. Well, 1 over x times x is just 1. Let's go ahead and take this derivative. Derivative of 6x is 6. For the next term, the 1/2 comes down. 3 times 1/2 is 3 over 2. X to the, now the exponent is 1/2 subtract 1, so you get negative 1/2. Derivative of 8 is 0. Now the last term, bring the negative 1/2 down. 4 times negative 1/2 is negative 2. X to the negative 1/2 subtract 1 gives you negative 3 over 2. I would leave that guy like that. Leave the exponents as they are unless you're asked to rewrite it. Now for this one, we can't factor the numerator to be able to divide out the denominator. We're going to have to use the quotient rule. So if we call the numerator p, and let's find the derivative of the numerator, the derivative of 2x cubed, bring the 3 down, you get 3x squared. Sorry, I keep hitting that with my hand. You get 3x squared. Derivative of negative 5x squared, negative 10x to the first. Derivative of 6 is 0. For the denominator, call it q. Derivative of x to the 7th is 7x to the 6th. Derivative of 2 is 0. So let's go ahead and write the derivative of this function. It's going to be, we're going to follow the quotient rule. Derivative of the numerator, which is 6x squared minus 10x minus, times the denominator. I'm going to run out of room. And I'm writing really crazy, sorry. I've got some really weird stylus here. And then minus the numerator, which is 2x cubed minus 5x squared plus 6 times the derivative of the denominator, 7x to the 6th. All of that is over the denominator squared. Now, my recommendation is that you just leave this guy the way that he is. Don't simplify it. And yes, this whole thing is that numerator. Sorry, my stylus is going crazy. And so keep all of this. Now, typically we leave it because we're looking for the derivative of certain x values, so we would just substitute in and simplify. Okay, here we go. Next one. This one, let's rewrite that root as an exponent. So f of x equals 5. Keep what's inside, x cubed minus 3x plus 1 all to the 1/2. That's just taking this root and making it exponential instead of in radical form. Now when we take this derivative, f prime, the 5 comes along for the bride. The 1/2, the exponent for this function inside comes down. We rewrite what's inside, then we're going to chain rule out. And so we rewrite what's inside, x cubed minus 3x plus 1. Subtract 1 from the exponent to get negative 1/2. And then chain rule out the derivative of what's inside. 3x squared minus 3. And then you're done. And so what we've done is bring the exponent down, keep what's inside, subtract 1. That's the power rule. But the extended power rule, which uses a chain rule, then chains out the derivative of what's inside. And at this point, we're done. We've got, you could write 5 over 2. You could multiply that in there. I don't recommend it. That just leave it like this, because what we do is evaluate derivatives at certain x values, and you could do that. Now, if you're looking for where it's equal to 0, then you would want to rewrite this as a fraction because he's negative, he's in the denominator. Then you could tell where it's undefined, where this is 0, where the fraction is 0, which is where this guy would be 0. One more. For this one, it looks like a quotient rule, but it really isn't. You can rewrite this as x squared plus 1 to the negative 3. And then we're going to use the power rule, extended power rule, or chain rule, whichever you call that. And so y prime is equal to, we're going to bring this exponent down, we're going to then subtract 1 from this exponent, rewrite this, and then chain rule out. So let's do that. Bring the negative 3 down. The coefficient is 1, so we still get negative 3. Rewrite what you have inside, x squared plus 1. Subtract 1 from the exponent, minus 3 minus 1 is negative 4. Then chain rule out the derivative of what's inside. And you're done. Now what a lot of people will do is go ahead and multiply this negative 3 and this 2x, because it's a really super simple step to give you negative 6x, x squared plus 1 raised to the negative 4. And then you can substitute in a value for x. You could write this guy in the denominator, so negative 6x over this to the 4th to make that positive, and then you could find out where it's undefined or where you get 0. And for this one, it's really interesting because this is never 0, and so you're only going to get 0 when the numerator is 0, which is at 0. So that's it. Keep practicing those derivatives.